there is a question. It is perhaps the deepest and oldest question. Why is there something rather than nothing? Stop for a moment. Look around you. There is a world. There are objects. There is light striking your eyes and air filling your lungs and blood moving through your veins. There are stars burning in a sky you cannot see right now, but which is there, above the ceiling, above the atmosphere, extending outward for tens of billions of light years in every direction. There is stuff, and the stuff is doing things. Atoms are vibrating, photons are streaming, galaxies are rotating, time is passing. Something, somewhere, is always happening. Why? Why any of this? Why is there a universe at all? The default state of reality, if there is such a thing as a default, would seem to be nothing. Emptiness, absence, a pure, unbroken void with no matter, no energy, no space, no time, no laws, no possibilities, no anything. Nothing is simple. Nothing requires no explanation. Nothing just is not. But we do not live in nothing. We live in something. An enormous, elaborate, complicated something. A cosmos of particles and forces and structures and patterns stretched across scales from the subatomic to the intergalactic, obeying laws so precise that we can predict the motion of planets centuries in advance and calculate the behavior of electrons with accuracy beyond 10 decimal places. Why? Why is any of this here? Why did the universe bother? The question in its modern form was first sharpened by the German philosopher Gottfried Wilhelm Leibniz, writing at the end of the 17th century. Leibniz phrased it precisely. Pourquoi il y a plutôt quelque chose que rien? Why is there something rather than nothing? He argued that this was the fundamental question, the one that had to be answered before any other question about reality could be truly understood. Every other question presupposes that there is a reality to ask questions about. But why is there such a reality? Leibniz's own answer was theological. He argued that the existence of the universe requires a sufficient reason, and that this reason must lie outside the universe itself, in a necessary being, God, whose existence explains itself and whose choice to create the world explains the world. For centuries, this was, for many, a satisfying answer. Then gradually it became less satisfying, because the question can be turned around. If God explains the universe, what explains God? If God is a necessary being that exists by its own nature, why not simply say the universe is a necessary being that exists by its own nature and skip the intermediate step? The theological answer, whatever its other merits, does not seem to actually dissolve the question. It just pushes it back one level. And when you push a question back one level, you have not answered it. You have only postponed it. Before we can ask why there is something rather than nothing, we have to ask what we mean by nothing. And this, it turns out, is much harder than it looks. In everyday language, nothing means the absence of stuff. An empty room, an empty box, an empty sky. But an empty room contains air. An empty box contains air and photons and the electromagnetic field and the quantum vacuum. An empty sky contains all of these things, plus starlight and cosmic rays and the faint whisper of the microwave background. None of these are really nothing. They're just spaces where the more obvious kinds of stuff are absent. To reach true nothing, we would have to remove everything, not just matter, but energy, not just energy, but space itself, not just space, but time, not just time, but the laws of physics, the mathematical structures, the possibilities, the potentialities, the very framework within which existence could occur. True nothing is not an empty room. True nothing is the absence of the room, the absence of the emptiness, the absence of the possibility of a room ever having existed. True nothing is not a thing. True nothing is not even a place. True nothing cannot be pointed at, described, imagined, or approached. The moment you begin to describe it, you have failed, because description requires categories, and categories are not nothing. And here's the strange thing. The more carefully you try to imagine true nothing, the more you begin to suspect that it may be impossible. Not just impossible to imagine. Impossible. Full stop. Perhaps nothing was never an option. Perhaps the universe exists because nothing cannot exist. Perhaps the absence of everything is, in some deep sense, incoherent, a state that cannot be because there is no be for it to occupy. If this is true, then the question, why is there something rather than nothing, has a startling answer, because nothing was never on the table. Modern physics has its own approach to this question, and it is a strange one. According to quantum field theory, the most successful physical theory ever devised, empty space is not empty. What we call the vacuum is actually a seething, boiling foam of activity. Virtual particles pop into existence and vanish again in impossibly brief flickers. Fields fluctuate at every point. Energy fluctuates. The vacuum is alive with a restless, uncontainable quantum jitter. And this jitter has consequences. The Casimir effect, which we have discussed before, demonstrates that the quantum vacuum can push on physical objects, that the fluctuations of empty space have measurable mechanical effects. The Lamb shift in the spectrum of hydrogen atoms is caused by the interaction of electrons with these vacuum fluctuations. The very stability of matter depends, in ways we are still uncovering, on the constant activity of what we naively call nothing. So when physicists ask why there is something rather than nothing, they sometimes give an answer that sounds almost dismissive. There is no such thing as nothing. Nothing is unstable. What we call nothing is actually something, a quantum vacuum with rich structure and immense creative potential. And out of this something, more elaborate somethings inevitably emerge. In this view, the universe is not a mystery to be explained. It is the natural consequence of the fact that pure emptiness is not a stable state. Given enough time, or given no time at all, in the timeless language of quantum mechanics, the vacuum will fluctuate. Particles will appear. Structures will form. Universes will arise. Not because anyone wills them to, but because the alternative, genuine, absolute nothing is not permitted by the laws of physics. This is, in some sense, an answer to Leibniz's question, but it is also a trick, because the answer only pushes the question back one level. Yes, quantum fluctuations can produce a universe out of a vacuum, but why is there a quantum vacuum? Why are there laws of physics that permit such fluctuations? Why is there a mathematical structure within which any of this can occur? The vacuum is not nothing. And explaining something by reference to another something is not explaining anything at all. In 2012, the physicist Lawrence Krauss published a book titled A Universe from Nothing, in which he argued that modern cosmology can, in fact, explain the origin of the universe from a state that is genuinely nothing, or at least close enough to nothing that the distinction ceases to matter. Krauss pointed to a remarkable feature of general relativity. The total energy of a closed universe, a universe that curves back on itself containing everything within a finite volume, may add up to exactly zero. Positive energy in the form of matter and radiation is balanced by negative energy in the form of gravitational attraction. When you sum it all up, every particle, every photon, every gravitational bond, the totals cancel. The universe in this view is a kind of cosmic zero-sum accounting. It contains an enormous amount of positive stuff and an equally enormous amount of negative gravitational potential, and the two exactly balance, which means that creating a universe requires no net energy at all, which means that a universe can, in principle, arise from a state of zero energy, which means, Krauss argued, that the universe can come from nothing. The response from philosophers was, to put it mildly, unimpressed, because Krauss's nothing was not the philosopher's nothing. Krauss's nothing was a quantum vacuum, obeying the laws of physics, embedded in a mathematical framework, existing within the context of general relativity and quantum field theory. That is not nothing. That is a very particular kind of something with very particular properties, capable of very particular behaviors. Philosophers pointed this out, sometimes gently, sometimes not. The theologian David Bentley Hart wrote scathing reviews. The philosopher of physics David Albert dismissed Krauss's argument as a category, error. Even sympathetic physicists acknowledged that Krauss had answered a question, but not the question. Krauss had shown that, given a certain kind of physical framework, universes can emerge without violating conservation laws. He had not shown why there is a physical framework at all. He had not shown why the laws of physics exist. He had not shown why there is anything for the laws to apply to. The deepest question remained deepest. And the universe from nothing was still, upon examination, a universe from something. There is another approach to the question, associated with the physicist Max Tegmark. Tegmark proposes what he calls the mathematical universe hypothesis. The idea is this: every mathematical structure that is logically consistent exists, not exists in the sense of being an idea in someone's head, not exists in the sense of being a useful abstraction, but exists physically, actually, in the same sense that our own universe exists. Our universe, in this view, is simply one particular mathematical structure among infinitely many. The equations of physics are not descriptions of an underlying reality. They are the reality. There is nothing else to the universe except its mathematical structure. No additional substance, no hidden essence, no metaphysical stuff underneath the numbers. And if every self-consistent mathematical structure exists, then the question, why is there something rather than nothing, has a strange answer. Because every mathematically possible something exists, necessarily by virtue of being mathematically possible. Nothing is not on the table because mathematics does not contain a nothing option. Mathematics contains structures. Some of those structures are our universe, some are other universes, some are cosmoses we cannot imagine. But they all exist because mathematical existence and physical existence are, in Tegmark's view, the same thing. This is a startling claim. It is also a claim that many physicists find deeply unsatisfying, because it seems to trade one mystery for another. Why does mathematics exist? Why is there a realm of mathematical structures at all? Why is anything, mathematical or otherwise, the case? The mathematical universe hypothesis, whatever its other merits, does not truly answer Leibniz's question. It just relocates the mystery from physics into mathematics. And mathematics, for all its beauty and power, is not obviously self-explanatory either. There is another kind of answer that some cosmologists offer. It goes like this: perhaps there are many universes, an infinity of them in fact, with different laws, different constants, different possibilities. Some of these universes contain the conditions for life. Some do not. We obviously live in one that does. We could not observe a universe incompatible with our existence, because in such a universe, we would not be here to observe anything. This is the anthropic principle, and when applied to the question of existence itself, it produces an answer of sorts. We ask why there is something rather than nothing because we are the kind of beings who exist in a something. If there were nothing, no one would be asking. The question presupposes its own answer. The very act of asking guarantees that the answer is because we are here to ask. There is a certain elegance to this, but there is also a certain evasion, because the anthropic principle does not explain why there is a multiverse. It does not explain why there are any universes at all. It only explains, given that some universes exist, why we find ourselves in a hospitable one. It answers a different question. It answers, why do we find ourselves in a universe capable of supporting us? It does not answer, why is there any universe at all? The anthropic principle is a filter. It tells us which universes we are likely to observe. It does not tell us why there is anything to filter. Some philosophers, following in Leibniz's footsteps, though not always with his theological conclusions, have argued that the answer to the question must involve some kind of necessary being. A necessary being is something that exists by its own nature, something whose existence is not contingent, not accidental, not dependent on anything else, something that could not, in principle, fail to exist. Contingent things, you, me, the earth, the sun, the Milky Way, depend on other things for their existence. They could have been otherwise. They could have failed to be. A necessary being is different. A necessary being must be, because its non-existence would be a contradiction. If such a being exists, and if it is the ultimate source of everything else, then it explains the universe. It exists because it must. Everything else exists because it does. The theistic tradition identifies this necessary being with God. Some philosophers identify it with abstract mathematical structures. Some identify it with the laws of physics themselves. Some identify it with existence itself, as a kind of self-supporting metaphysical foundation. But there is a problem with all of these answers. It is not clear that the concept of a necessary being is even coherent. What would it mean for something to exist necessarily by its own nature? What would prevent us from imagining its non-existence? Why should we accept that any particular thing, God, mathematics, physical law, is exempt from the requirement of explanation while everything else is not? The necessary being, whatever it is, seems suspiciously convenient. It seems to be defined precisely so as to solve the problem, and no more, which is not, strictly speaking, an argument, but it is a discomfort. And the discomfort for many thinkers has not gone away. Let us try for a moment to actually imagine the alternative, not to describe it, not to characterize it, just to imagine, as best we can, a state in which nothing whatsoever exists. No matter, no energy, no space, no time, no possibilities, no potentials, no laws, no mathematics, no logic, no structure of any kind. Not darkness, because darkness is a something, an absence of light within a space where light could have been. Not silence, because silence is a something, an absence of sound within a domain where sound could have occurred. Not stillness, because stillness is a something, an absence of motion within a place where motion could have been. Just nothing. No perspective from which to view it. No time during which it occurs. No place where it happens. No is, no was, no would have been. Try to hold this image in your mind. Try to imagine it for even a fraction of a second. You cannot. Not because you are not smart enough, not because you have not thought about it hard enough, but because the very act of imagining requires an imaginer, and the imaginer is a something, and a something cannot be present in nothing. The moment you conceive of nothing, you have failed, because your conception is itself a something. And here is where the question begins to look very strange indeed. If we cannot even coherently imagine true nothing, if the very concept collapses under examination, then perhaps nothing was never a real alternative to something. Perhaps the question, why is there something rather than nothing, is like asking, why is there a triangle rather than a round square? The alternative is not another possibility we passed over. The alternative is not a possibility at all. The alternative is a phrase that seems meaningful, but when examined is not. If this is true, then existence is not a puzzle to be solved. Existence is the only game in town. There was never anything else. There could never have been anything else. But even this, in the end, is not fully satisfying. Because even if nothing is incoherent, even if the alternative to something is not a real alternative, we can still ask, why is there this particular something? Why this universe with these laws, these constants, this history? Why atoms and not something else? Why gravity and not some other force? Why 3 spatial dimensions and 1 temporal one and not some other combination? Why 13.8 billion years of cosmic history and not some other duration? Even if existence itself is necessary, the form of existence is not obviously necessary. And so the question mutates, it becomes, why is there this rather than that? And this question is, in its own way, just as deep as the original. We do not know why the constants of nature are what they are. We do not know why the laws of physics take the forms they do. We do not know why our universe emerged from the Big Bang in exactly the way it did. We can describe, we can measure, we can predict, but we cannot, at the deepest level, explain. We can trace the history of the cosmos back to a fraction of a second after the Big Bang. We can describe in exquisite mathematical detail what happened as the universe expanded and cooled. We can watch in the cosmic microwave background the faint afterglow of an event that happened before there were stars. But we cannot ask why the Big Bang was what it was. We cannot ask what came before. We cannot ask why the initial conditions were arranged just so. At some level, perhaps very deep, perhaps just beyond our current understanding, the questions stop being scientific. They become metaphysical. They become the kind of questions that no experiment can settle and no equation can resolve. And at that level, we are back where Leibniz started 3 centuries ago, asking a question that will not go away. Not because we are asking it wrong, but because it is the deepest question there is. Perhaps we have been thinking about this incorrectly all along. Perhaps, why is there something rather than nothing, is not a question that admits of an answer in the ordinary sense. Perhaps it is not a question like, why is the sky blue? Or, why does the apple fall? Questions that have specific, describable, verifiable answers. Perhaps it is a question that exists to be asked, not to be answered. A question that reveals something about the asker rather than the world. A question that opens a door onto a kind of wonder that no answer could ever close. Consider what happens when you sit with the question, really sit with it, not to solve it, but simply to feel its weight. Something shifts, the ordinary world, the room you are in, the objects around you, the body you inhabit, begins to look different. Not stranger exactly, but more remarkable, more improbable, more surprising. You start to notice that there is that reality is happening, that whatever else is true, whatever else remains uncertain, something is going on, something is here, something is being. And this bare, brute fact of being is the most extraordinary thing there is. Not the details, not the laws, not the histories or the galaxies or the atoms, just the sheer staggering fact that anything at all is the case. The philosopher Ludwig Wittgenstein wrote, near the end of his Tractatus, that it is not how things are in the world that is mystical, but that it is. That is the mystery, not what the world is like, but that there is a world at all. Here is a strange and beautiful thought. Whatever the answer to Leibniz's question, whether there is one, whether there could be one, whether the question even makes sense, one thing is undeniable. We are asking it. We, pieces of matter, arrangements of atoms, temporary configurations of the same elements that make up rocks and stars and empty space, are asking why there is something rather than nothing. The universe, through us, is inquiring into its own existence. The cosmos is looking at itself and wondering how it got here. Think about that. For 13.8 billion years, matter has been arranging itself. Hydrogen fused into helium in the cores of the first stars. Those stars died and scattered heavier elements. Those elements gathered into new stars, new planets, new worlds. On at least one of those worlds, perhaps on many, the elements gathered themselves into structures complex enough to move, to feel, to think, to ask questions. The atoms in your body are, quite literally, the atoms of the universe. There is no dividing line between you and the cosmos. You are not a separate observer looking in from outside. You are the cosmos, folded into a shape complex enough to reflect on itself. And when you ask why there is something rather than nothing, the universe is asking itself. This is not mysticism. This is not poetry. This is a straightforward description of what is happening when a human being contemplates the existence of the universe. The universe is contemplating the universe. Whatever the answer to the question, or the impossibility of an answer, this fact remains extraordinary. Reality, whatever it is, has become self-aware in at least a few places. And in those places, it looks at itself and asks why. You will not solve this tonight. You will not solve it in your lifetime. Humanity, if it survives long enough, may never solve it at all. The question of why there is something rather than nothing may be the one question that outlives every civilization, every species, every era. It may be the question that the last conscious being in the universe, whoever and whatever they are, is still asking as the last light fades. And this is not a failure. This is not a defeat. This is perhaps the most fitting possible relationship between a mind and its cosmos. To be capable of asking the deepest question, to be incapable of answering it. To live suspended between the two, between the reach of the question and the silence of the answer, is to occupy a peculiar and precious position in reality. We are the creatures who wonder. We are the arrangements of matter through which the universe wonders about itself. And whether there is an ultimate answer, or whether the question dissolves upon deeper analysis, or whether the whole thing is a beautiful confusion of language and thought, we get to ask. We get to sit under the stars and wonder why the stars are there. We get to look at our own hands and wonder why hands exist. why matter arranges itself into hands, why there is a universe in which hands are possible. We get to hold the question, turn it in our minds, feel its weight, and pass it on to those who come after us. That is not nothing. That, in fact, is one of the most remarkable things any part of the universe has ever done. So we return, in the end, to where we began. Why is there something rather than nothing? We do not know. We may never know. Perhaps the question has no answer. Perhaps it has an answer we cannot access. Perhaps it dissolves into meaninglessness when examined closely enough. Perhaps it points to a mystery that lies at the very foundation of reality, a mystery that cannot be dispelled because it is not a puzzle to be solved, but a truth to be encountered. But the question is here. We ask it, and the universe, through us, listens to itself asking. Somewhere in the vast dark, on an ordinary planet orbiting an ordinary star in an ordinary galaxy, a species of upright mammal has developed the capacity to look at existence and demand a reason for it. We have not received a reason. We may never receive a reason, but we have received something else. We have received the world, the trees, the oceans, the mountains, the other people whose faces we know and whose voices we love, the animals, the stars, the books, the music, the languages, the mathematics, the dreams, the mornings and the evenings and the long unfolding of days. All of it, every scrap, every moment, every ordinary miracle is here. For no reason we understand, for no purpose we can name, for no cause we can trace to any ultimate source. It is simply, impossibly, wonderfully here. And perhaps that is enough. Perhaps in the end, the question is not one that demands an answer. Perhaps the question is one that demands a response. And the response is not a theory. The response is not an equation. The response is not a philosophy or a theology or a doctrine of any kind. The response is to live, to pay attention, to notice, to love what is here, while it is here, in the brief flicker of consciousness that has been granted to you between two eternities of silence. Because whatever else is true, whatever is finally, ultimately, cosmically the case, this much cannot be denied. There is something rather than nothing, and you are part of it. And that, in its way, is the deepest answer we may ever have. Long before there were physicists, before there were philosophers in the modern sense, before there were even books to write questions down in, human beings were asking this question. We know this because the earliest surviving records of human thought, the oldest hymns, the oldest myths, the oldest poems carved into clay and stone, return again and again to the same fundamental puzzle. How did the world come to be? What was there before? Why is any of this here? The oldest written creation story we possess comes from Sumer, more than 4,000 years ago. In it, the world begins with a vast primordial sea called Namu, from which the sky and the earth emerge. Before Namu, there is nothing described. Not because there was nothing, but because language itself falters at the edge of that emptiness. The Sumerians could imagine a beginning. They could not quite imagine a not beginning. The ancient Egyptians told a similar story, though with different characters. In the beginning, they said, there was none, a formless, boundless, dark, watery abyss. Out of none rose the first mound of land, and upon that mound, the first God willed himself into being. But even here, in this stark theology of self-creation, the abyss precedes the God. Something was there, even if it was only water, even if it was only darkness. even if it was only the raw potentiality of what would later become the cosmos. The Rig Veda, composed in India more than 3,000 years ago, contains one of the most philosophically remarkable passages ever written on this subject. In the Nasadya Sukta, the hymn of creation, the ancient poet writes, "There was neither non-existence nor existence then. There was neither the realm of space nor the sky which is beyond. What stirred? Where? In whose protection? Was there water, bottomlessly deep? And then, most remarkably of all, whence this creation has arisen, perhaps it formed itself, or perhaps it did not, the one who looks down on it, in the highest heaven, only he knows. Or perhaps he does not know. 3,000 years ago, in a language that would eventually give rise to Sanskrit, an anonymous poet acknowledged that perhaps even the gods do not know why anything exists. Perhaps even the gods are as puzzled as we are. Perhaps the question runs deeper than divinity itself. The ancient Greeks, when they turned their sharp minds to this problem, produced a diversity of answers. Thales said everything came from water. Anaximenes said everything came from air. Heraclitus said everything came from fire. Empedocles said everything came from a mixture of 4 elements. Democritus said everything was made of atoms swirling in a void. But behind all of these specific answers lurk the same haunting question. Why is there stuff at all? Why is there water, or air, or fire, or atoms? Why is there anything for the philosophers to argue about? Parmenides, perhaps the strangest of the pre-Socratics, went further than any of his contemporaries. He argued that nothing cannot exist, not merely as a practical matter, but as a logical impossibility. To speak of nothing is to speak of something, he pointed out, and therefore nothing cannot be spoken of. And if nothing cannot even be spoken of, then it cannot be. Therefore, whatever exists must always have existed, and whatever does not exist could never have come to be. Parmenides was probably wrong about several things, but he identified with startling clarity the paradox at the heart of the question we are asking. The moment you try to describe nothing, you have made it into something. And something once made cannot be unmade, at least not without leaving some trace, some absence, some structure where the something used to be. This is not a modern insight. This is an insight that human beings have been circling around for at least 4,000 years. We have been asking this question longer than we have had cities, longer than we have had agriculture in some places, longer than we have had almost any recorded institution of any kind. And we still do not have an answer. The medieval meditations. The question did not disappear with the fall of the ancient world. It went into the monasteries and the madrasas and the yeshivas, where scholars in 3 faiths spent centuries wrestling with it. The medieval Christian tradition, drawing on Aristotle, developed the doctrine of creatio ex nihilo, creation out of nothing. God, in this framework, does not shape pre-existing material into a world. He calls the world into being from absolute nothingness by an act of pure will. This was a bold claim. It was also a claim that raised immediate problems. If God creates the world from nothing, what does it mean to say that nothing was there beforehand? Nothing is not a place. Nothing is not a substance. Nothing is not a canvas on which God can paint. So what precisely is God doing when he creates the world from nothing? The medieval theologians had answers of a sort. Thomas Aquinas argued that creation from nothing does not mean creation from a nothing that exists. It means creation without any pre-existing material. God simply causes the world to be, and there is no prior stuff involved in the causing. But this leads to another problem. If God's act of creation is not spatial or temporal or material, if it is, in some deep sense, entirely outside the categories of ordinary causation, then what does it even mean to say that God caused the world? The Islamic philosopher Al-Ghazali, writing in the 11th century, argued that the very concept of cause and effect requires a temporal sequence. First the cause, then the effect. But time itself is part of the created world. So there is no first and then before time exists. The question of what caused the universe, therefore, may be a category error. It may be asking a temporal question about something that is not temporal. Al-Ghazali's response to this puzzle was, ultimately, to fall back on faith. God's creative act, he said, is a mystery that human reason cannot fully penetrate. We can know that the universe has a cause. We cannot fully understand what such a cause is like. The Jewish philosopher Maimonides, writing shortly after Al-Ghazali, took a similar view. God, he argued, is not a being like other beings. God does not exist in the same way that a tree or a stone exists. God's existence is of an entirely different kind, necessary rather than contingent, timeless rather than temporal, unconditioned rather than conditioned. When we ask why God exists, we are, in Maimonides' view, misusing the word why. The question presupposes a framework of causation that only applies to created things. Applied to the creator, it collapses. This is elegant. It is also, one might say, convenient, because it exempts the one thing we most want to explain from the requirement of explanation. Every contingent thing must have a cause, except for the necessary thing that causes everything else. The necessary thing gets a free pass. Why? Because we have defined it as the thing that gets a free pass. The critics of medieval theology were not slow to notice this move. If we are allowed to postulate a necessary being that explains itself, why not simply say that the universe is the necessary being? Why not skip the middleman? The theologians had answers to this too. The universe, they said, is manifestly contingent. It changes. It has parts. It could have been otherwise. A necessary being must be simple, unchanging, and self-sufficient. And the universe, plainly, is none of these things. But this reply raises its own problems. It assumes we know what a necessary being would have to be like. It assumes that simplicity and unchangingness are the marks of necessity. And these assumptions, while intuitive, are not obviously true. The medieval debate rumbled on for centuries. It produced some of the most sophisticated metaphysical reasoning in human history. It also, in the end, did not resolve the question. The question was still there when Descartes picked it up in the 17th century. The question was still there when Leibniz sharpened it into its modern form. The question is still there now. René Descartes, sitting in a heated room in the Netherlands in the winter of 1619, set out to doubt everything he could possibly doubt. His goal was to find something, anything, that could not be doubted, and to build a philosophy on that foundation. He doubted the evidence of his senses. Perhaps he was dreaming. He doubted the truths of mathematics. Perhaps an evil demon was deceiving him about even the simplest sums. He doubted the existence of the external world. Perhaps nothing outside his mind was real at all. And then he found the one thing he could not doubt. Cogito, ergo sum. I think, therefore I am. The very act of doubting proves that there is a doubter. The very act of thinking proves that there is a thinker. Whatever else may be uncertain, the existence of the thinking self is undeniable, because to deny it is to think it, which confirms it. Descartes had found his foundation. But then he ran into the deeper question. Having established that he existed, Descartes had to ask why he existed. And having asked that, he had to ask why anything existed. And having asked that, he found himself facing the same abyss that had swallowed every philosopher before him. Descartes' answer was theological. God, he argued, is a necessary being, and God's existence explains everything else. But Descartes went further than most of his predecessors. He tried to prove God's existence, not by appeal to scripture or tradition, but by pure reason. His argument went like this: I have within my mind an idea of a perfect being. This idea is so perfect, so complete, so infinite, that it could not have come from within me. For I am finite and imperfect. Therefore, the idea must have been placed in my mind by something that actually possesses those perfections. That something is God. This argument was not new. Anselm of Canterbury had made a version of it 600 years earlier, but Descartes gave it a new twist, tying it to his epistemological project. God in Descartes' system is not merely the creator of the world. God is the guarantor of knowledge. Without God, we cannot trust our senses. Without God, we cannot trust mathematics. Without God, we cannot even trust our own reasoning. The problem with this argument is that it seems to assume what it is trying to prove. If we already accept that our idea of God corresponds to a real being, then of course God exists. But why should we accept that? Why should the fact that I can imagine something perfect mean that something perfect actually exists? I can imagine a unicorn. Unicorns do not exist. I can imagine a perfect island. Perfect islands do not, so far as we know, exist. Why is God different? Descartes had answers. His critics had counter-answers. The debate went on and continues to go on and shows no signs of resolution. But Descartes did something important, whatever we think of his specific arguments. He made the question of existence a question of first philosophy. He put it at the foundation of everything else. He said, in effect, before we can know anything, we must know why anything is. And in doing this, he sharpened the question in ways that continue to shape how we think about it today. The question is not merely one of many puzzles. The question is the puzzle that lies beneath all other puzzles. Every scientific inquiry, every philosophical investigation, every act of asking why, all of it presupposes that there is a something to be inquired about. And the question of why there is a something is, in that sense, prior to every other question we could possibly ask. We cannot investigate our way past it. We can only stand before it and wonder. Some years after Descartes, in the same Netherlands, a lens grinder named Baruch Spinoza offered an answer to the question that has haunted thinkers ever since. Spinoza's answer was radical. It was so radical that he was excommunicated from his Jewish community for it. It was so radical that he refused to publish his major work during his lifetime, knowing it would provoke fury. It was so radical that when it appeared after his death, it was banned across most of Europe. Spinoza said, "There is only one substance. There is only one thing that exists in the deepest metaphysical sense. And everything else, every tree, every star, every human mind, every thought, is a mode of that one substance." He called this substance Deus sive natura. God or nature. For Spinoza, the distinction between God and the universe was a mistake. There is no creator standing outside the world, shaping it from without. The universe is not a made thing. The universe is what there is. And the universe is, in some sense, self-explaining, because it could not have been otherwise. Everything that exists, Spinoza argued, exists necessarily. Every event that occurs, occurs necessarily. There is no contingency in reality, no room for things to have been different. The world unfolds exactly as it must unfold, because it is the only world that could exist. This is a striking answer to Leibniz's question, why is there something rather than nothing? Because there could not have been nothing. Because the something that exists is necessary, self-caused, self-explaining. Because reality, at its deepest level, is the kind of thing that must be. Many philosophers have found this answer unsatisfying. It seems to assert rather than argue that the universe is necessary. It seems to redefine God in a way that empties the word of most of its traditional meaning. It seems to eliminate freedom, choice, and moral responsibility by making everything a matter of iron necessity. But some philosophers have found it profound. Einstein, when asked whether he believed in God, famously replied that he believed in Spinoza's God. Not a personal God who rewards and punishes, not a creator who shapes the world according to his will, but a God who is identical with the ordered lawfulness of nature, a God who is simply the deep, necessary structure of reality itself. For Einstein and for many others in the scientific tradition, Spinoza's answer had a certain appeal. It located the source of existence not in some external agency, but in the very fabric of what is. It said, in effect, the universe explains itself because there was never any alternative. But even Spinoza's answer, however elegant, faces the same objection that has been raised against every other attempt to solve this puzzle. Why is the necessary substance the way it is? Why does it have these attributes rather than those? Why does it manifest as this particular universe with these particular laws rather than as some other configuration? Spinoza has answers to these questions too, worked out in dense geometrical style across the propositions of his ethics. But the answers depend on definitions and axioms that not everyone accepts. And when you push them hard enough, they seem to circle back to the same brute fact. Reality is the way it is. And we cannot, from within reality, step outside to ask why. When we hear that the universe began with the Big Bang and has been expanding ever since, we naturally picture an explosion. A point in space from which matter flew outward in all directions, spreading into a pre-existing emptiness. This picture is intuitive. It is also fundamentally wrong. The Big Bang did not happen at a point in space. It happened everywhere at once. Space itself was compressed into a state of extreme density and heat, and then that space began to expand. Every point in what is now the universe was, at that moment, part of the hot, dense state. Every point is, in a sense, the origin of the expansion, and every point continues to be, in that same sense, the center of the expansion today. If you were standing in any galaxy in the observable universe, you would see other galaxies moving away from you in every direction, and you would appear to be at the center of the expansion. So would an observer in any other galaxy. So would an observer trillions of light years away if such distances contain observers. There is no privileged center because the expansion is not happening in space. It is an expansion of space itself. The metric of space-time, the rule that determines how distances are measured, is changing over time in such a way that any 2 points not held together by local forces are drifting apart. This has implications that go beyond cosmology. It means the universe does not have a location. It is not somewhere within a larger container. It contains all the somewheres there are, and there is no external vantage point from which one could observe its position or its shape. To ask where the universe is to ask a question that has no meaning. It also means that our intuition about beginnings, that something must begin at a place, fails when applied to the universe as a whole. The universe did not begin at a place because there were no places prior to the universe. Places came into being with the universe itself. Space is not the stage on which cosmic history is performed. It is one of the actors, changing and growing along with everything else. And it forces us to reconsider what an explosion even means at the largest scales. An ordinary explosion propagates through a medium, air, water, empty space, that pre-exists the event. The Big Bang had no such medium. It was not the propagation of matter through space. It was the appearance of space itself, along with the matter and energy that populate it. Nothing about ordinary experience prepares us to picture such a thing, and every metaphor we try to use, balloon, explosion, birth, falls short in a different way. The ordinary matter that makes up stars, planets, dust clouds, and living beings, the atoms of the periodic table, in every form they take, accounts for roughly 5% of the total mass energy content of the universe. The remaining 95% is divided between two substances, or perhaps two aspects of reality that we have never directly observed and do not fully understand. Dark matter, which makes up about 27% of the universe, has never been detected in any laboratory. We know it exists, or that something exists that behaves like it, because galaxies rotate in ways that cannot be explained by the gravity of visible matter alone. If you calculate how fast the outer regions of a spiral galaxy should be moving, given only the mass we can see, you get a much smaller number than the number we actually measure. The stars at the edges of galaxies orbit far too fast to be held in by the visible gravitational pull. Something else must be there, providing additional gravity. This something else also bends light in ways that reveal its distribution, and it shaped the growth of structure in the early universe in ways that are visible in the cosmic microwave background. But what dark matter is remains one of the great open questions of physics. Decades of increasingly sensitive experiments have searched for particles that might account for it. Weakly interacting massive particles, axions, sterile neutrinos, primordial black holes, and other candidates. So far, no candidate has been confirmed. The most sensitive detectors, buried deep underground to shield them from ordinary radiation, have set stricter and stricter limits on what dark matter cannot be, without yet identifying what it is. Dark energy, which makes up about 68% of the universe, is stranger still. It is the name we give to whatever is causing the expansion of the universe to accelerate rather than slow down. In the 1990s, observations of distant supernovae revealed that the universe is not merely expanding, but expanding faster and faster over time. This was not what anyone expected. The gravity of matter should be slowing the expansion. Something must be pushing space apart against gravity and pushing harder as the universe grows larger. Whatever this something is, it behaves like a kind of pressure built into empty space itself. It has a constant density that does not dilute as space expands, which means that as more space appears, more dark energy appears with it. If this description is correct, the far future of the universe is one in which dark energy comes to dominate everything, tearing structures apart and eventually pushing distant galaxies beyond the horizon of what we can see. But we do not know what dark energy is. It might be a cosmological constant, a property of vacuum itself. It might be a dynamic field that changes over time. It might indicate that our theory of gravity is incomplete and needs modification at the largest scales. The reality we inhabit is, by mass and energy, almost entirely composed of substances we cannot detect and do not understand. The visible universe of stars and galaxies is a thin, luminous scum on an ocean of the unknown. And when we speak of existence, we are speaking mostly of things whose nature is still hidden from us. If you took a region of space and removed every particle, every atom, every photon, everything you could possibly remove, you would not end up with nothing. You would end up with what physicists call the quantum vacuum. And the quantum vacuum is a seething, restless thing. Because of the Heisenberg uncertainty principle, empty space cannot have a precisely defined energy at any given moment. The energy of the vacuum fluctuates, and these fluctuations correspond to the continuous appearance and disappearance of pairs of virtual particles. A particle and its antiparticle, briefly existing, briefly interacting, and then annihilating one another back into the void. This is not a theoretical curiosity that we have to take on faith. It has measurable consequences. The Casimir effect, first predicted in 1948 and confirmed experimentally in the years since, involves two parallel metal plates placed very close together in a vacuum. The plates restrict which virtual particles can appear between them. The virtual particles outside the plates are not so restricted. The result is a net inward pressure that pushes the plates toward each other, and the magnitude of this force matches the theoretical prediction to high precision. The vacuum also contributes to observed properties of atoms. The Lamb shift, a tiny difference between the energy levels of hydrogen atoms that classical theory cannot explain, arises from the interaction of electrons with the fluctuating electromagnetic field of the vacuum. The anomalous magnetic moment of the electron, one of the most precisely tested predictions in all of physics, depends on vacuum effects. So the vacuum is not nothing. It has structure. It has energy. It has effects that ripple through everything else. This raises a philosophical question of some depth. Much traditional thinking about existence has taken nothing as the natural default and has treated the presence of something as the thing that requires explanation. Why is there something rather than nothing? The question presupposes that nothing is a coherent alternative, that reality could have been empty, and that we need to explain why it is not. But if the quantum vacuum is the closest thing to nothing that physics allows, and if the quantum vacuum is already full of activity, then the traditional notion of nothing may not correspond to any physically realizable state. Nothing in the strict sense may be impossible. And if nothing is impossible, then the presence of something is no longer the anomaly it seemed. The anomaly is the very idea of nothing, an idea we can form in language but cannot instantiate in reality. This does not fully answer the ancient question, but it changes its shape. We are no longer asking why reality departs from an achievable state of emptiness. We are asking why reality has the particular kind of non-emptiness it has, and why that non-emptiness includes us. Measurements of the cosmic microwave background, the faint radiation left over from the early universe, which fills all of space and has been mapped in extraordinary detail by satellites like WMAP and Planck, suggests that the large-scale geometry of the universe is flat, or as close to flat as we can measure. This has a precise meaning. In a flat universe, parallel lines remain parallel forever. The angles of a triangle add up to exactly 180 degrees, and the geometry of Euclid, which we learn in school, applies at cosmic scales. In a curved universe, by contrast, these familiar rules would break down. In a positively curved universe, shaped like the surface of a hypersphere, parallel lines would eventually converge, and triangles would have angles summing to more than 180 degrees. In a negatively curved universe, saddle-shaped in some higher dimensional sense, parallel lines would diverge, and triangle angles would sum to less than 180 degrees. The universe could, in principle, have any of these three geometries. Our best measurements indicate that it is flat to within a small margin of error, perhaps within a fraction of a percent. But flatness is a razor's edge. The equations of general relativity, when applied to a uniformly filled universe, show that any deviation from perfect flatness grows over time. If the universe had started slightly positively curved, that curvature would have amplified enormously as the universe expanded. The same is true for slight negative curvature. Only exact flatness is stable. Any departure from it snowballs. For the universe to appear flat today, after 13.8 billion years of expansion, it had to have been almost exactly flat at very early times. Calculations suggest that the deviation from flatness 1 second after the Big Bang could not have been larger than about 1 part in 10 to the 15th power. Push back further to the earliest moments we can meaningfully discuss, the required precision becomes even more extreme, 1 part in 10 to the 60th power, or more. This is one of the finest tunings we know of in nature. It is not the only one. The relative strengths of the fundamental forces, the mass of the Higgs boson, the value of the cosmological constant, and several other parameters appear to be balanced with astonishing exactness against alternatives that would have produced a very different universe, or no universe at all. Cosmic inflation, the hypothesis that the very early universe underwent a brief period of exponential expansion, was proposed largely to explain the flatness. During inflation, whatever curvature was originally present would have been stretched out to near zero, in the way that any patch of an inflating balloon looks flatter and flatter as the balloon grows. Inflation, if correct, explains flatness without requiring the initial conditions themselves to be finely tuned. But inflation raises its own questions. Why did inflation happen? What field or mechanism drove it? Why did it end when it did, leaving behind a universe with just the right properties for structure to form? The tuning does not so much disappear as retreat to a different level. And there is a further wrinkle. Some versions of inflationary theory imply that inflation, once started, keeps going forever in some regions, producing an endless multiverse of pocket universes with varying properties. In this picture, our observed flatness is not a mystery, but a selection effect. We happen to inhabit a pocket where flatness prevails, because only such pockets produce observers to notice. Whether this is a genuine explanation or a retreat from explanation is much debated. What is clear is that flatness is not a trivial feature of the universe. It is a puzzle, and a puzzle that connects directly to the deepest questions about why our universe is the way it is. For most of the history of physics, matter and energy were taken as the basic constituents of reality. Everything that exists was thought to be, at bottom, some arrangement of stuff, particles, fields, waves, moving and interacting according to laws. In the last several decades, a growing body of theoretical work has suggested that this picture may have things backward. Information, not matter, may be the most fundamental feature of reality. The physicist John Archibald Wheeler, one of the most influential figures in 20th century physics, summarized this view in the phrase, "it from bit." Every it, every particle, every field, every physical entity we can identify derives, on Wheeler's view, from bits of information, from answers to yes or no questions. Matter is the visible manifestation of an underlying informational structure. The universe is, in some sense, a vast computation, or the record of a vast computation, whose outputs are the physical events we observe. This idea, once speculative, has received support from several unexpected directions. Work on black holes has revealed that the entropy of a black hole, a measure of the amount of information it contains, is proportional not to its volume, as we might have expected, but to the area of its event horizon. This is a strange result. In ordinary physics, the amount of information that can be stored in a region grows with the region's volume. Double the space, double the storage. But for black holes, the storage capacity is set by the surface, not the interior. The information required to describe everything inside a black hole is encoded somehow on its two-dimensional boundary. This observation led to the holographic principle, first proposed by Gerard 't Hooft and developed further by Leonard Susskind and others. The holographic principle suggests that this feature of black holes is not a peculiarity of black holes, but a general feature of gravity and space-time. The information required to describe any region of space, on this view, is encoded on the boundary of that region, not throughout its interior. The three-dimensional world we experience may be, in a precise mathematical sense, a projection of information encoded on a lower dimensional boundary, a hologram of a deeper reality. This is not merely a metaphor. In certain well-studied model universes, anti-de Sitter spaces, which have particular geometric properties that make them tractable, there is a rigorous mathematical duality between the physics inside the space and a quantum field theory defined on its boundary. Every question about the interior can, in principle, be answered by computations on the boundary and vice versa. The two descriptions are equivalent, even though they involve different numbers of dimensions and different physical entities. Whether our universe, which has different geometric properties from anti-de Sitter space, obeys an analogous duality is not yet known. But the mathematical existence of such dualities suggests that our intuitive picture of matter existing in three-dimensional space may be one of several possible descriptions of a reality whose deeper nature is informational. If information is more fundamental than matter, the reality we take for granted, solid, spatial, made of stuff, is a kind of representation. The underlying reality is more abstract, more like a pattern of correlations than a collection of things. Existence, on this view, is closer to a structure of relationships than to a substance. This has consequences for how we think about ourselves. If we are, at bottom, patterns of information, then what makes us who we are is not the specific atoms that currently constitute our bodies, atoms that are, in any case, constantly being replaced through metabolism, but the information encoded in the arrangement of those atoms. And information, unlike matter, is the kind of thing that could, in principle, be preserved, copied, or transferred. Whether any of this is technologically achievable, or whether it would preserve what matters about a person, are separate and difficult questions. But the very framing of these questions depends on taking information seriously as a fundamental category. In our everyday experience, time flows. The past is fixed and unchangeable. The future is open and yet to be determined. The present is where we live, the moving edge at which possibility becomes actuality. We seem to move through time from earlier to later, as if drifting along a river whose current carries us inexorably forward. This picture is so deeply built into how we think that questioning it can feel like questioning the ground beneath our feet. but it is difficult to reconcile with modern physics. In Einstein's theory of relativity, time is a dimension of space-time, analogous in important ways to the three dimensions of space. Different observers moving relative to one another do not agree on which events are simultaneous. An event that is happening now for one observer may be in the past for another observer and in the future for a third. Simultaneity is relative, not absolute. There is no universal now that all observers share, and no cosmic clock ticking off moments that everyone can agree on. This is not a philosophical speculation. It is a well-tested consequence of relativity. GPS satellites, for instance, must correct for the difference between the rate at which their clocks tick and the rate at which clocks on the ground tick, because relativity predicts that these rates will differ due to the satellite's motion and their altitude in Earth's gravitational field. If we did not make these corrections, GPS would be useless within hours. Time, in the sense captured by clocks, is not the same for all observers. More broadly, the equations of physics, from Newton's laws to general relativity to the equations of quantum field theory, are, with one exception involving certain weak force interactions, symmetric under time reversal. The laws do not distinguish past from future. They describe how systems evolve, but they do not embed any preferred direction of that evolution. The apparent flow of time and the asymmetry between past and future that we experience so vividly does not appear anywhere in the fundamental equations. This has led many physicists and philosophers to the view known as the block universe. On this view, past, present, and future are all equally real. The whole of space-time exists as a single, four-dimensional structure, a block in which every event that ever has happened and ever will happen is present. Time does not flow because there is nothing for it to flow through. It simply is, in the same way that space simply is. On this view, the sense of flow we experience is a feature of consciousness, not of reality. Our brains, moving through the block along their particular world lines, register successive states. Memory encodes earlier states. Anticipation reaches toward later ones. The vivid feeling of a moving present is a byproduct of how minds like ours process information about our position in space-time. The moving present is not out there in the world. It is a feature of how we experience the world. If this picture is correct, the consequences are profound. Every moment of your life is, in some sense, permanent. Your birth is real, right now, at its own location in space-time. Your death, whenever it happens, is also real, at its own location. Every joyful moment you have ever had continues to exist, not as a memory, but as an actual event embedded in the four-dimensional structure of reality. So does every painful one. Nothing that has happened is lost. Nothing that will happen is unreal. The passage of time on this view is not something that happens. It is something we do. It is a way of encountering a reality whose fundamental structure is not temporal in the way we usually imagine. Whether the block universe view is correct is genuinely uncertain. Some philosophers and physicists resist it, arguing that it fails to account for the felt reality of temporal passage, or that it misrepresents the actual content of physical theory. Others accept the block universe but argue that it does not eliminate the flow of time so much as reconceive it. The debate is active and it touches on some of the oldest questions in philosophy: whether the future is fixed, whether the past is closed, whether we are truly free. What is clear is that our most basic sense of what it means to exist, to be located in a flowing present, moving from moment to moment, may be a kind of illusion produced by minds that evolved to navigate a small corner of a much stranger reality. the speed of light in a vacuum, the gravitational constant, the mass of the electron, the fine structure constant which governs the strength of electromagnetic interactions, Planck's constant, the ratios that relate the masses of the fundamental particles, the strengths of the strong and weak nuclear forces. These numbers appear in the equations of physics as fixed values. We call them the constants of nature, and we have measured them with extraordinary precision. The fine structure constant, for instance, is known to about 1 part in a billion. These values enter into everything from the structure of atoms to the burning of stars, and small changes in them would produce dramatically different worlds. But there is no known theoretical reason why these constants should have exactly the values they do, and there is no proof that they are truly constant. Consider the fine structure constant, denoted by the Greek letter alpha. Its numerical value is approximately 1 over 137.036, and this pure number appears throughout atomic physics. If it were significantly larger, atoms would be less stable, chemistry would be different, and the kinds of complex structures needed for life might be impossible. If it were significantly smaller, nuclear reactions in stars would proceed differently, and the abundance of elements in the universe would be altered. The observed value seems to be nestled in a narrow range that permits complex chemistry and long-lived stars. Why? No one knows. In the current framework of physics, the fine structure constant is an input, not a prediction. We measure it, but we cannot derive it. And the same is true of most of the other constants. The question of whether the constants have always been exactly what they are today has been investigated observationally. If the fine structure constant were significantly different in the distant past, the light emitted by atoms in ancient stars and gas clouds would show slight shifts in the wavelengths of its spectral lines. Astronomers have looked for such shifts by analyzing light from very distant quasars, whose light has been traveling to us for billions of years. Some measurements have hinted at tiny variations in the fine structure constant across cosmic distances and cosmic times. In one much discussed set of observations, a team of astronomers reported that the fine structure constant appears to have been slightly smaller in one direction of the sky and slightly larger in the opposite direction when measured across billions of light years. Other groups using different methods and different data have found results consistent with no variation at all. The situation is unresolved. The effects, if real, are extremely small, a change of a few parts per million at most, but even small variations would have enormous theoretical implications. If any of the constants varies in time or space, then the laws of physics as we know them are not permanent universal features of reality. They are the local values of parameters that might, in other eras or other regions, take different values. The universe we inhabit would be revealed as a particular configuration, one that happens to have the properties it has here and now, rather than as a necessary structure. This connects to a further speculation. Some theoretical frameworks, particularly those associated with string theory and the multiverse, suggest that the constants of nature are not fundamental at all, but are set by the details of how certain hidden dimensions are configured. In this picture, there could be many possible configurations, each corresponding to a different universe with different physical laws. The values we observe are the values that happen to hold in our particular universe. In other universes, the values might be different, and most of those universes might be radically inhospitable to any kind of structure or life. Whether such other universes exist is not something we can currently determine. but the possibility that our physical constants are contingent rather than necessary, that they might have been otherwise and might yet vary, is a live one. And it reshapes how we should think about the specificity of the reality we inhabit. The three dimensions of space we experience, length, width, and depth, feel like they exhaust the possibilities. Any direction we can point in is some combination of these three. Any location can be specified by three coordinates. There is no fourth spatial direction available to us in any observable way. But some of the most influential theoretical frameworks in modern physics require additional dimensions to work. String theory, in its various formulations, requires either 10 or 11 dimensions of spacetime for the mathematics to be self-consistent. Since only 4 of these are observed, 3 of space and 1 of time, the remaining 6 or 7 must, according to the theory, be curled up so small that they cannot be detected by any experiment yet performed. They would be present at every point in space, wrapped into tiny compact shapes at scales far below what any accelerator can probe. To picture this, imagine a long garden hose seen from a great distance. From far away, it looks like a one-dimensional line. Only when you get closer do you see that it has a second dimension, a small circle wrapped around each point along its length. The extra dimensions of string theory, if they exist, are like this. At the scales of ordinary experience, they are invisible. At scales approaching the Planck length, around 10 to the minus 35th meters, they would become significant, and the extra spatial directions would open up. The specific shapes into which the extra dimensions are curled matter enormously in string theory. Different shapes produce different low-energy physics, meaning different particles, different forces, and different constants. If our universe corresponds to one particular way of compactifying the extra dimensions, then the properties of the physical world we observe are consequences of that geometric choice. Change the shape, and you would change the physics. This raises the question of why the compactification took the particular form it did in our universe. Some versions of string theory imply that there are astronomically many possible compactifications, the so-called string theory landscape, each corresponding to a different possible universe. Our universe would then be one point in a vast space of possibilities. The reason our physics is what it is would be, in part, that only universes with certain properties can support observers who ask such questions. Whether string theory is correct is not yet known. It remains a mathematical framework in search of experimental confirmation, and it has proven remarkably difficult to test. The energies at which the effects of extra dimensions would become visible are far beyond anything we can produce in the laboratory. Some physicists have grown skeptical of the whole approach, arguing that a theory that cannot be tested cannot be considered science in the ordinary sense. But the very fact that our best attempts at unifying gravity with the other forces of nature seem to require extra dimensions is itself striking. Whatever the final verdict on string theory, the possibility that the reality we inhabit has more dimensions than we can perceive is a serious one, taken seriously by many of the most careful thinkers in the field. If it turns out to be true, then the world we see and touch is a low-dimensional projection of a higher dimensional whole. What we take for the full reality is a slice, and the fuller reality is inaccessible to our senses in principle, not merely in practice. The universe is roughly 13.8 billion years old. This is not an arbitrary figure, and it is not, on reflection, an inconsequential one. For life like ours to exist, several things had to happen in a particular order, and each of them took a particular amount of time. The first stars had to form. This required the universe to cool sufficiently after the Big Bang for neutral atoms to form, then for those atoms to gather under gravity into dense enough clouds to ignite into stars. This process took roughly 100 to 200 million years. Those first stars had to live out their lives and die. The most massive of them, which burned hottest and fastest, exhausted their nuclear fuel in a few million years and exploded in supernovae. These explosions were essential because they seeded the universe with elements heavier than helium. In the extreme temperatures and pressures of stellar cores, hydrogen and helium had been fused into carbon, oxygen, nitrogen, silicon, iron, and the other elements that would eventually make up planets and living things. Only when stars died could these elements be released into the interstellar medium, where they could become raw material for the next generation of stars and planets. But a single generation of stars was not enough. The very first stars produced only some of the elements we need. Later generations of stars, formed from the ashes of earlier ones, produced richer mixtures. It took several generations of star formation and stellar death, spanning billions of years, before the interstellar medium became chemically rich enough to produce a planet like Earth, with its diverse chemistry and its liquid water. Then a suitable star had to form. The Sun is a third-generation star, formed about 4.6 billion years ago from a cloud of gas and dust that had been enriched by earlier stellar generations. It is stable, long-lived, and located in a relatively quiet region of the galaxy, none of which was guaranteed. Then a planet had to form around that star in the right kind of orbit, with the right kind of composition, with liquid water, with a stabilizing moon, with a magnetic field to protect its atmosphere from solar wind, and with an active geology that could recycle nutrients and moderate the climate. All of this took further hundreds of millions of years. Then life had to begin. When exactly this happened on Earth is not certain, but there is evidence of microbial life within perhaps a few 100 million years of the planet's formation. This early life was simple, single-celled, and would remain so for most of Earth's history. Then life had to become complex. For roughly 2 billion years after life first appeared, it remained microscopic. Only around 600 to 700 million years ago did the first multicellular animals appear. Only about 500 million years ago did the Cambrian explosion produce the great diversity of animal body plans from which everything descended. Only about 200,000 years ago did anatomically modern humans emerge. Only in the last few thousand years did civilization begin. Only in the last few centuries did modern science develop. Only in the last few decades have we had the tools to measure the age of the universe. Add all of this up, and you find that the universe had to be at least somewhere around 10 to 14 billion years old to produce beings capable of asking how old it is. Not much less, or the necessary stellar and biological evolution would not have had time. And, remarkably, this is the age we find it to be. This alignment is not chaos, a coincidence in any simple sense. It reflects what philosophers call the anthropic principle, the observation that any universe that contains observers must, by that fact alone, satisfy the conditions necessary for observers to exist. We could not have found ourselves in a universe too young to have produced us. The correlation between the universe's age and the age at which observers appear is a selection effect, not a mystery. But there is a deeper puzzle. Why does the universe last long enough for observers to appear at all? Why does the expansion proceed at just the right rate, not so fast that structures cannot form, not so slow that everything collapses back on itself before life has a chance? Why are the physical laws such that stars can exist, that they can produce heavy elements, that those elements can combine into the molecules of life? Why is there a hospitable window in cosmic history, one that includes us, during which conscious beings can look out at the world and reflect on what they see? We appear to be living in that window right now. Before our era, the universe was too hot, too young, too structurally simple. Long after our era, in the deep future, the stars will burn out, matter will decay, black holes will evaporate, and the universe will settle into a dark, cold, mostly empty state in which no complex structures can persist. The stretch of cosmic time in which stars shine, planets orbit, and life can flourish is limited. We happen to exist within it. That we happen to exist within it is, in one sense, inevitable. We could not exist outside it. But that any such window exists at all remains one of the great open questions. We come finally to the deepest of the obscurities. Physics has been extraordinarily successful at describing how the universe behaves. It gives us equations of motion, laws of interaction, principles of symmetry, and predictions that match observation to breathtaking precision. It tells us with increasing detail and confidence how things happen and how they are related. But there is a question that physics does not answer and appears constitutionally incapable of answering. Why is there anything at all? Every physical explanation takes something for granted. When we explain the motion of a planet, we take the existence of the planet and the star for granted and appeal to laws of gravity. When we explain the existence of the planet, we take the existence of the primordial cloud from which it formed for granted and appeal to processes of gravitational collapse. When we explain the primordial cloud, we take the existence of the early universe for granted and appeal to the processes of cosmic evolution. When we explain the early universe, we take the existence of the initial state for granted and appeal to whatever theory we have of that state: inflation, quantum cosmology, string theory, or something else. At every stage, we explain things by appeal to prior things. But this cannot continue indefinitely. Either the chain of explanation eventually reaches something that has no prior explanation, a brute fact, or it loops back on itself, or it terminates in something whose existence explains itself. The first option, a brute fact, means that there is a most fundamental level of reality whose existence is simply given. It cannot be explained by anything more basic because there is nothing more basic. Physics, on this view, ends in mystery. The second option, a loop, has been proposed in some speculative frameworks in which the universe somehow causes itself, or in which time is closed rather than linear. But it is hard to make sense of what it would mean for a thing to explain its own existence in a genuinely non-circular way. The third option, a self-explaining reality, is what philosophers and theologians have sometimes reached for: something whose essence is to exist, something whose non-existence is impossible. Such an entity, if it exists, would provide the terminus of explanation. But its very possibility is contested, and the traditional arguments for its existence remain philosophically controversial. Whatever the resolution, physics itself cannot supply it. The methods of physics presuppose the existence of things to study and the laws that govern them. Physics can describe what those things are and how those laws work. It cannot, from within its own resources, explain why there are any things at all, or why the laws are as they are, or why anything holds together in the first place. Some physicists have suggested that the question, why is there something rather than nothing, is meaningless, or that it rests on a confusion. Perhaps nothing is not a coherent possibility, as the discussion of the quantum vacuum earlier suggested. Perhaps the very framing of the question smuggles in assumptions that cannot be sustained. But even if the question in that particular form is problematic, the underlying wonder remains. Whatever the ultimate structure of reality turns out to be, a quantum vacuum, a multiverse, a mathematical structure, a divine mind, or something we cannot yet imagine, its being here, rather than not, is the fact around which everything else revolves. It is the fact from which all other facts derive their possibility. And it is the fact that physics, for all its power, must simply accept as given. This is not a defect of physics. It is a limit built into any descriptive enterprise. To describe is to say what is the case. It is not to explain why there is anything to describe. The strangeness at the heart of existence is not something we are gradually going to eliminate through further research. It is not a temporary gap in our knowledge that will be filled by a better theory. It is a structural feature of the situation we find ourselves in, and any adequate response to it will have to be something more than an equation. The 18th century brought new challenges to the question and to every proposed answer. David Hume, the Scottish philosopher, took his skeptical scalpel to the traditional arguments for God's existence. He pointed out that the concept of cause and effect, which the medieval theologians had used to argue from the world's existence to a first cause, is itself a psychological habit rather than a logical necessity. We see one event follow another, and we come to expect that one caused the other. But we do not, in any strict sense, perceive causation. We only perceive succession. If causation is a habit of mind rather than a feature of reality, then the argument from cause to first cause loses its footing. We cannot conclude from the fact that things in the world seem to be caused that the world as a whole must have a cause. Hume also challenged the argument from design, the claim that the ordered complexity of the world points to an intelligent designer. He pointed out that we have no experience of universes being made. We have no way to compare our universe to other universes and infer from the comparison what kind of causes tend to produce what kind of cosmoses. The whole argument, Hume said, rests on an analogy, the analogy between the universe and a machine, that we have no way to verify. Hume did not offer an alternative answer to the question of why anything exists. He simply pointed out that the traditional answers were less secure than they seemed, but his skepticism cleared the ground for a new kind of thinking. Immanuel Kant, working in the shadow of Hume's arguments, tried to salvage what could be salvaged. He argued that some questions are simply beyond the reach of human reason. The question of why anything exists, in Kant's view, is one of them. It is not a bad question. It is not a meaningless question. But it is a question that transcends the categories through which we understand the world and therefore admits of no definitive answer. Kant called these ultimate questions the antinomies of pure reason. They arise necessarily whenever human beings think carefully about the deepest features of reality, but they cannot be resolved by the tools of thought. We can prove, Kant argued, that the world must have had a beginning in time. We can also prove, with equal rigor, that the world cannot have had a beginning in time. We can prove that everything must have a cause. We can also prove that there must be something uncaused. The arguments on both sides are valid, but they contradict each other. And the contradiction, Kant argued, is not a failure of reasoning. It is a sign that we have reached the limits of what reason can do. Beyond those limits, there is only silence, or if you prefer, faith, or if you prefer, wonder, but not knowledge in the strict philosophical sense. Kant's position was, in its way, humbling. It said, the deepest question you can ask is one you cannot answer, not because you are not smart enough, but because the question, by its very nature, transcends the framework within which answers can be given. This is not skepticism about the world. It is skepticism about our capacity to comprehend the world at its deepest level. And it is a position that many thinkers in many traditions have found themselves returning to across the centuries. The question is real. The question is important. The question is, in some fundamental sense, unanswerable. Heidegger and the forgetting of being. In the 20th century, the German philosopher Martin Heidegger took up the question with new intensity. Heidegger believed that Western philosophy for 2,500 years had been asking the wrong question, or rather, had been asking the right question in the wrong way. Philosophers had been so busy investigating particular beings, this thing, that thing, the various types of things that populate the world, that they had forgotten the more fundamental question of being itself, not the question of what exists, but the question of what it means to exist, not the question of why this or that particular thing is here, but the question of why there is anything to be here at all. Heidegger called this die Seinsfrage, the question of being. And he argued that it was the question that had been systematically forgotten by the entire philosophical tradition since Plato. The forgetting, in Heidegger's view, was not accidental. It was a consequence of the way human beings ordinarily engage with the world. We move through our lives absorbed in tasks, projects, concerns. We deal with tools, with objects, with other people. We do not ordinarily stop to notice that any of it is there. The sheer fact of being, the astonishing, inexplicable presence of a world, recedes into the background. We take it for granted, we forget it, and in forgetting it, we lose access to the deepest dimension of our own experience. Heidegger thought that certain rare moods could break through this forgetfulness. Anxiety, in particular, not ordinary worry about specific things, but a deeper, more diffuse dread, has the power to strip away our absorption in the everyday and reveal the strangeness of existence. When you are seized by that kind of anxiety, the familiar world becomes unfamiliar. The chair is no longer just a chair. The room is no longer just a room. Everything you took for granted suddenly stands out as remarkable, contingent, precarious. You notice, perhaps for the first time in years, that there is a world. And the noticing brings with it the question, why is there something rather than nothing? Heidegger called this the fundamental question of metaphysics. He opened one of his most important lectures with it, and he returned to it throughout his career. But he did not claim to answer it. He claimed rather that the question itself was the thing worth attending to. The point was not to find a solution and move on. The point was to dwell in the question, to let it work on you, to let it undo your assumptions, to let it reveal what ordinary experience conceals. For Heidegger, philosophy was not a puzzle-solving activity. It was a way of remaining in contact with the deepest strangeness of what is. This is a very different picture of philosophy from the one that dominates most contemporary universities. It is more like poetry than like science. It is more like meditation than like argument. It aims not at conclusions, but at a certain kind of wakefulness. And it points toward an answer of sorts. not an answer that dissolves the question, but an answer that transforms the questioner. The response to why is there something rather than nothing is for Heidegger not a proposition but a way of living. To live in awareness of the question is already to have partially answered it, because the question is not just asking about the world. The question is asking about you, about your own strange, temporary, incomprehensible presence in a reality that did not have to include you and will not, in the end, retain you. To hold that question with steadiness is to become more fully what you are. To forget it is to fall back into the ordinary sleep from which most human lives are lived. Heidegger's answer, if we can call it that, is not an answer at all in the usual sense. It is an invitation. Wake up. Notice. The fact that anything is here, including you, is the only miracle you will ever need. The 20th century physicists. While Heidegger was pursuing his meditations in the Black Forest, the physicists were reshaping our understanding of what it even means for something to exist. Quantum mechanics had emerged in the 1920s, and it brought with it a picture of reality so strange that no one, including its inventors, quite knew what to make of it. Particles could be in multiple places at once. Observation seemed to affect what was observed. Randomness appeared to be built into the fabric of nature at the deepest level. The neat, deterministic clockwork universe of Newton had been replaced by something far more slippery and elusive. And within quantum mechanics, the concept of nothingness itself underwent a transformation. The vacuum, the state of lowest energy, the closest thing to absolute emptiness that physics allows, turned out to be not empty at all. Fields fluctuate. Virtual particles appear and vanish. Energy shimmers into and out of existence in an endless microscopic churn. The vacuum has structure. It has properties. It can be manipulated, measured, and even, in certain experimental setups, made to yield up observable effects. The Casimir effect, first predicted in 1948, demonstrated this concretely. Place two uncharged metal plates very close together in a vacuum, and they will experience a small but measurable attractive force. This force cannot be explained by any classical mechanism. It arises because the geometry of the plates restricts which vacuum. Fluctuations can occur between them, and this restriction creates a pressure imbalance. The vacuum, in effect, pushes the plates together. If this seems like a small and technical result, consider what it implies. The nothing between the plates is doing something. The nothing has mechanical consequences. The nothing is, in some sense, not nothing. Physicists were forced to distinguish between different kinds of nothingness. There is the everyday nothing, an empty room, a bottle with the air pumped out, a region of space between stars. This kind of nothing is obviously not truly nothing. It contains fields, radiation, and vacuum fluctuations. Then there is the quantum vacuum, the state of lowest possible energy, the deepest emptiness that physics can achieve. But even this is a something. It obeys laws. It has properties. It is not the metaphysical nothing that philosophers have in mind when they ask Leibniz's question. Can we get to the metaphysical nothing? Can we, even in principle, describe a state that has absolutely no properties, no laws, no structure, no existence? The consensus among most physicists is probably not. The very act of description imposes structure. Even to say there is no space is to invoke the concept of space and then negate it, which is not the same as space being absent from the ontology altogether. The metaphysical nothing may be, in a strict sense, undescribable, not because it is beyond our current abilities, but because description itself cannot reach it. If this is true, then physics cannot answer the deepest form of the question. Physics can tell us how the universe evolved from a very hot, dense early state. Physics can tell us how galaxies formed and stars ignited and planets coalesced. Physics can trace the causal chain of events back to fractions of a second after the Big Bang. But physics cannot tell us why there is a universe to evolve. Physics cannot tell us why there are laws for the universe to obey. Physics cannot tell us why there is anything for physics to describe. At some point, perhaps at the moment of the Big Bang, perhaps at some deeper level of explanation we have not yet reached, physics runs out. The equations still work, but they no longer explain anything more fundamental. They are, at that point, the fundamental thing. And the question of why the fundamental thing is fundamental, why this framework rather than another, why any framework at all, is not a question that physics can pose within its own methods. It is a question that physics inherits from philosophy and passes on unanswered. The multiverse as an answer. In recent decades, some physicists have offered a new kind of answer to Leibniz's question. It is not, strictly speaking, an answer to why there is something rather than nothing. But it is an answer to a related question. Why is there this particular something? The answer is, there isn't just this particular something. There are many. Perhaps infinitely many. The multiverse hypothesis, in its various forms, proposes that our universe is one of a vast, perhaps unlimited collection of universes. Some of these universes have laws similar to ours. Others have very different laws. Some are hospitable to life. Most are not. We find ourselves in one of the hospitable ones because we could not have found ourselves anywhere else. This is an application of the anthropic principle to the largest possible stage, and it has a certain explanatory appeal. It removes the puzzle of fine-tuning, the strange fact that the constants of nature seem carefully arranged to permit the existence of complex structures like galaxies, stars, planets, and living beings. In a multiverse, no fine-tuning is required. The constants take every possible value across the ensemble of universes. We find ourselves in one where they happen to permit us. That is all. But the multiverse hypothesis does not answer Leibniz's question. It answers a smaller question and pushes the larger one back a level. Why is there a multiverse? Why is there whatever mechanism produces the many universes? Why is there a mathematical structure within which such a mechanism can operate? The multiverse, whatever its virtues as a scientific hypothesis, does not escape the deepest puzzle. It just relocates it. Instead of asking why our particular universe exists, we now ask why the multiverse exists. And the same considerations that made the original question so difficult make the new question equally difficult. If anything, the multiverse hypothesis makes the puzzle sharper, because it implies that reality is unimaginably vaster than we had supposed, not just billions of galaxies, not just billions of stars, but an entire ensemble of cosmoses, each one containing its own galaxies and stars, and possibly its own conscious beings, all of them existing without any apparent reason for existing. The multiverse does not explain existence. It multiplies it. And every additional universe you postulate is one more thing that needs, in principle, an explanation for its existence. Some physicists respond to this by saying that the multiverse is, in some sense, self-explaining. If every possible universe exists, then no explanation is needed for why any particular universe exists. Its existence is guaranteed by the completeness of the ensemble. But this reply just moves the question again. Why does the complete ensemble exist? Why is possibility itself instantiated? We can keep chasing the question backward, but at every stage, we find ourselves facing the same wall. Something is here. We do not know why, and no amount of multiplication, of universes, or of levels of explanation seems to bring us closer to an answer. The simulation hypothesis. In the last 2 decades, a new candidate answer has emerged, one that combines features of ancient theology with modern computer science. The simulation hypothesis, as articulated most influentially by the philosopher Nick Bostrom in 2003, proposes that our universe may not be a fundamental physical reality at all. Instead, it may be a computational simulation running on some kind of hardware that exists in a larger, more fundamental reality outside our own. The argument for taking this seriously goes something like this. If it is possible in principle for advanced civilizations to create simulated universes containing conscious beings, and if such civilizations are likely to create many such simulations, then the number of simulated conscious beings will vastly exceed the number of original conscious beings in any base reality. By purely statistical reasoning, therefore, a randomly selected conscious being is more likely to be in a simulation than in a base reality. You, dear listener, are a randomly selected conscious being. Therefore, you are probably in a simulation. This is an unsettling argument, and it has generated a great deal of discussion. But for our present purposes, what matters is what it does to Leibniz's question. At first glance, the simulation hypothesis seems to offer a new kind of answer to the question of why anything exists. Our universe exists because someone, some advanced civilization, some cosmic programmer, created it. The stars are pixels. The laws of physics are code. The whole thing is, in a sense, an artifact. But this answer, like every other proposed answer, only pushes the question back. Why does the simulating civilization exist? Why does the base reality within which the simulation runs exist? Why is there any kind of reality, simulated or otherwise, for questions like this to be asked in? The simulation hypothesis, whatever else it does not dissolve the fundamental puzzle. It introduces one more level of causation, one more layer of explanation, one more possible source for the world we experience. But the ultimate question, why is there anything at all, remains untouched by any number of intermediate causal layers. Even if we are in a simulation, someone or something must exist unsimulated, and that unsimulated existence, whatever it is, however it is arranged, is still at its foundation a something rather than a nothing. The mystery survives every proposed explanation. The mystery is, in some sense, immune to explanation of any conceivable kind, because every explanation must invoke something. And the invocation of something is not the eliminations of the mystery of somethingness. It is just its transfer from one location to another. The question in Eastern thought. We have been tracing this question primarily through the Western philosophical tradition, but it would be a mistake to think that this tradition has a monopoly on it. Similar questions, sometimes framed differently, sometimes leading to different conclusions, have been asked across Eastern thought for at least as long. The Buddhist tradition, in particular, has a rich engagement with the puzzle of existence, though it approaches it from an angle that Western thinkers often find surprising. In classical Buddhist metaphysics, the question of why anything exists is not treated as a demand for an ultimate cause. Instead, the tradition tends to focus on the interdependent nature of all phenomena. Nothing exists in isolation. Everything that exists depends on other things which depend on still other things in a vast web of mutual conditioning called pratyasamutpada, or dependent origination. This is not quite an answer to Leibniz's question, but it is a reframing of it. Instead of asking, why is there something rather than nothing? The Buddhist tradition asks, what is the nature of what exists? And the answer it gives is, what exists is not a collection of independent substances, but a flow of interdependent processes. The world is not a set of things that happen to be here. The world is a happening, a constant mutual arising and dissolving in which nothing has fixed independent being. If this is true, then the question of why there is something rather than nothing may be based on a misunderstanding of what something is. We imagine that something refers to solid, independent entities that could be present or absent. But if nothing is like that, if all existence is process rather than substance, then the alternative between something and nothing may not be as sharp as it seems. Existence, in this view, is not a static condition. Existence is what happens, and it happens moment by moment in an unfolding that has no clear starting point and no clear cause outside itself. The Taoist tradition, meanwhile, gives us the concept of Wu, often translated as nothingness or emptiness, as a positive and even generative principle. The Tao Te Ching famously says that the 10,000 things arise from being and being arises from non-being. The primal source of all phenomena is not a thing but a kind of pregnant emptiness, a formless potential out of which forms emerge. This is strikingly close in some ways to the modern physical concept of the quantum vacuum. Both traditions posit a foundational nothingness that is not actually empty, but is charged with creative possibility. And both traditions are careful not to identify this generative emptiness with the kind of absolute nothingness that would preclude all existence. The Hindu tradition, in its many strands, offers a variety of answers. Some schools posit an eternal, self-existing Brahman as the ultimate reality, a necessary being not unlike the one proposed by medieval Western theologians. Other schools treat the question of ultimate origin as a distraction from the practical work of liberation. Still others engage in sophisticated metaphysical speculation about the relationship between being, consciousness, and reality that rivals anything in the Western tradition. What emerges from all of this is that the puzzle of existence is not a Western puzzle. It is a human puzzle. Every serious philosophical tradition in every part of the world has confronted it in some form, and no tradition has definitively solved it. The question is universal. The absence of an answer is also universal. Perhaps this tells us something. Perhaps the question is one that arises inevitably in any sufficiently reflective mind, in any culture, in any era. Perhaps it is built into the very structure of consciousness itself, the mind's inevitable response to the fact of its own presence in a reality it did not ask for and cannot fully comprehend. Or perhaps it is a question that human minds are simply not equipped to answer, no matter what tradition they belong to or how carefully they think. Either way, the question is not going away. It has not gone away in 4,000 years of civilization. It is not likely to go away in whatever time we have left. Let us return for a moment to one of the classical arguments about existence, the argument from contingency. The argument goes like this: everything we encounter in the world seems to be contingent. It exists, but it did not have to exist. This tree could have failed to grow. This mountain could have failed to form. This universe could have failed to arise. Contingent things depend on other things for their existence, and those things depend on still others, and so on. But this chain of contingent dependencies cannot go on forever. At some point, either the chain closes on itself in an impossible circle, or it stretches back into infinity without ever grounding itself, or it terminates in something that is not contingent, something that exists necessarily by its own nature and does not depend on anything else. The first two options seem incoherent. A circular chain of dependencies cannot ground itself. An infinite regress of dependencies never actually grounds anything. Therefore, the chain must terminate in a necessary being. This is, in various forms, the most influential argument for the existence of a first cause or a necessary being that has ever been offered. It has been made by Aristotle, by Aquinas, by Leibniz, and by countless other thinkers across the centuries, and it continues to attract defenders in contemporary philosophy. But it has also attracted critics, and their objections are worth considering. The first objection is that the argument assumes that every contingent thing must have an explanation. This is called the principle of sufficient reason. But is it true? Perhaps some things simply exist without any explanation at all. Perhaps the universe is one of those things. If the principle of sufficient reason is not universally valid, then the argument from contingency loses its footing at the very first step. The second objection is that even if we accept the argument, its conclusion is remarkably thin. It tells us that there must be a necessary being. It does not tell us what that being is like. It does not tell us that this being is God in any traditional sense. It does not tell us that this being is conscious or good or personal or capable of hearing prayers. The necessary being of the argument from contingency might turn out to be something as impersonal as the laws of physics, or as abstract as a mathematical structure, or as strange as something we have no concept of at all. The third objection is that the concept of necessary existence is problematic. We can imagine, without contradiction, the non-existence of any particular thing. Even things that seem most solid and enduring, mountains, stars, galaxies, can be imagined as not existing. So what does it mean to say that some being exists necessarily in a way that could not fail to be? The concept seems to require that the non-existence of the necessary being would be a contradiction. But what contradiction? Where is the logical impossibility? The defenders of the argument have offered various answers, but none has convinced the critics. The fourth objection, perhaps the most powerful, is that even if we grant the existence of a necessary being, we have not really answered Leibniz's question. We have simply relabeled the mystery. Instead of asking why the universe exists, we now ask why the necessary being exists. And the answer, because it is necessary, feels less like an explanation than like a stipulation. To say that something exists necessarily is to say that it exists because it must exist. But this is not an explanation of its existence. It is a description of its mode of existence. The question of why anything has this necessary mode of existence, why necessity itself has any purchase on reality, remains open. We can push the mystery around. We can locate it in different places. We can call it by different names, but we cannot apparently dissolve it. Every proposed answer runs into the same wall. At some point, we have to say, this is the way things are, and there is no further explanation to be given. And whether we call that final, unexplained thing God, or the universe, or the multiverse, or a necessary being, or an abstract mathematical structure, or the quantum vacuum, or something else entirely, we are in the end making the same move. We are pointing at something and saying, this is where explanation stops. The question is whether any of these stopping points is more justified than the others. Whether there is a principled reason to say that reality bottoms out in one kind of thing rather than another, or whether the choice of stopping point is ultimately a matter of taste, tradition, or intuition. Philosophers disagree about this as they disagree about almost everything. The debate goes on, and the question remains unanswered. The grammar of the question. Some philosophers, particularly in the 20th century, have taken a different approach to the puzzle. Instead of trying to answer the question, they have tried to dissolve it, to show that the question itself is somehow malformed, and that once we understand what is wrong with it, the puzzle disappears. The most influential version of this approach comes from the ordinary language philosophers, especially in Britain in the mid-20th century. Thinkers like J.L. Austin, Gilbert Ryle, and the later Wittgenstein argued that many philosophical puzzles arise because we take everyday concepts and apply them in contexts where they no longer make sense. When we do this, we generate pseudo-questions that seem meaningful but are, on closer inspection, incoherent. The question, why is there something rather than nothing, might be one of these pseudo-questions. Consider what we usually mean by why questions. When we ask why the kettle is boiling, we are asking for a causal explanation. The flame is heating the water, transferring energy to the molecules, causing them to move faster until they change phase. When we ask why the government passed a particular law, we are asking for a motivational explanation. Legislators had certain goals, faced certain pressures, made certain calculations. When we ask why 2 plus 2 equals 4, we are asking for a mathematical justification. The axioms of arithmetic, combined with the definitions of the numbers, guarantee the result. In each of these cases, why makes sense because there is a framework within which the question can be answered. Causal explanations operate within the framework of physical laws. Motivational explanations operate within the framework of human psychology. Mathematical justifications operate within the framework of formal systems. But when we ask why there is something rather than nothing, what framework are we operating within? There is no larger context outside of existence itself. There is no meta level from which we can evaluate the fact that anything is here. The question seems to demand an explanation that transcends every possible framework, and this may not be a coherent demand. If this analysis is correct, then Leibniz's question is not a question that has no answer. It is a question that is not really a question at all, a grammatical construction that mimics the form of a question but lacks the substance that would make it meaningful. The problem is not that we cannot find the answer. The problem is that the question, when examined carefully, does not have the kind of meaning that could admit of an answer in the first place. This is a bold claim, and it is not, of course, universally accepted. Critics of this approach have pointed out that it seems too quick. We can meaningfully ask, they say, why there is this rather than that, even when the choice is between very fundamental alternatives. Why is there matter rather than antimatter? Why are there 3 spatial dimensions rather than 4? Why does time have a direction? These questions have been posed and, in some cases, partially answered by physicists. If we can ask why there is this particular something rather than some other particular something, why can we not ask why there is any something rather than nothing? The defenders of the dissolution approach have replies. They point out that questions about particular features of the universe operate within the framework of natural science, which is itself a something. There is a context, the observed universe, its laws, its history, against which such questions can be posed. But the question about existence as such has no such context. It attempts to step outside every possible framework, and the attempt fails not because we lack the tools, but because there is no outside to step into. Whether this response is convincing is a matter of ongoing debate. What is clear is that the question, whatever its exact status, refuses to be settled. If it is a genuine question, we do not know how to answer it. If it is a pseudo question, many of the most thoughtful minds in human history have failed to see this and continue to treat it as meaningful. Either way, the puzzle persists. Either way, we are left staring at the fact that anything is here and finding no way to make our staring resolve into understanding. The void that was never there. Let us try one more angle on this ancient problem. Suppose that nothing, absolute, complete, structureless nothing, is not actually a coherent possibility. Suppose that when we try to imagine it, we always fail, and that this failure is not a limitation of our imagination, but a reflection of a deeper truth about reality. If nothing is impossible, then the alternative to something never existed. There was never a state of nothingness from which something might or might not have emerged. There was never a fork in the road at which reality could have chosen to be or not to be. Reality does not choose to exist. Reality does not spring from a prior void. Reality just is. Because the alternative on this view is not a real alternative, but a linguistic phantom. This might be called the no void thesis. It has a certain appeal. It seems to dissolve the puzzle by denying one of its premises. If nothing is impossible, then the question, why is there something rather than nothing, collapses. There cannot have been nothing. There could not have been nothing. The question presupposes a possibility that does not exist, but the no void thesis raises its own problems. Why is nothing impossible? What is it about reality that rules out non-existence? If nothing is impossible, this seems to be a substantive claim about the nature of reality, a claim that itself requires explanation. And explaining why nothing is impossible looks suspiciously like explaining why there is something rather than nothing, dressed up in different words. We seem to be caught in a loop. If nothing is possible, we need to explain why something exists rather than nothing. If nothing is impossible, we need to explain why nothing is impossible. Either way, we face a demand for explanation that resists satisfaction. Perhaps the honest response is to acknowledge that we do not know whether nothing is a coherent possibility. We do not know whether the alternative to existence is a real alternative or a phantom of language. We do not know whether the puzzle is genuine or dissolvable. We just know that when we sit with it, when we try to think it through, we run out of thinking somewhere before the bottom. The mind reaches a place where it can go no further. And what lies beyond that place, if anything lies beyond it, is not something we can bring back and hold in our hands. The silence of the stars. There is a curious feature of our situation that deserves attention. For all our questioning, the universe does not answer. We look up at the night sky, and the stars burn silently. We probe the microwave background, and it whispers only of temperatures and densities. We examine the fine structure of matter, and it reveals patterns but no explanations. Whatever the universe knows about itself, it is not telling us in any language we can understand. This silence is not hostile. It is not deliberate. It is not, so far as we can tell, meaningful in any conventional sense. It is just there. The universe unfolds according to its own laws, indifferent to our curiosity. Galaxies rotate, stars burn, planets orbit. Life, in the small pockets where it has arisen, does what life does. And through it all, no voice ever speaks from the heavens to explain what any of it is for. Some people find this silence terrifying. They interpret it as evidence that the universe is meaningless, that human life is absurd, that our questions echo into a void that will never answer them. Others find the silence peaceful. They interpret it as an invitation, not to demand answers, but to look, to listen, to notice what is already here without insisting that it justify itself. Still others find in the silence a kind of dignity. The universe, they say, does not owe us an explanation. It does not exist for our benefit. It does not conform to our expectations. Its indifference is not a rejection, but a form of majesty. We are small creatures in a vast reality that outstrips us in every direction, and this is not a diminishment, but a wonder. However you interpret it, the silence is a fact. We ask and no answer comes. We reach out and nothing reaches back. We stand at the edge of the deepest question we can pose, and the question itself seems to be all we are given. Perhaps this is what the mystics of every tradition have been trying to communicate, that the final response to the ultimate question is not a proposition, but a silence, that the truth of existence is not something that can be said, but only encountered, that the deepest understanding comes not from answering the question, but from becoming still enough to let the question rest. Or perhaps not. Perhaps the mystics are as lost as the rest of us, just decorating their bewilderment with more elaborate language. But there is something in the silence itself that seems to matter. Something that is not solved by any of the theories we have proposed. Something that will still be there when we are gone. The question inside the questioner. Let us turn the question inward. We've asked why there is something rather than nothing. Why is there a universe? Why is there matter? Why is there space and time in the whole grand architecture of what exists? But there is a smaller, more intimate version of the same question that we sometimes forget to ask. Why is there you? Not why is there a human species? Not why is there life in the universe? But why is there this particular, specific, unrepeatable point of view? The one that is reading these words right now, hearing them in the private theater of your own consciousness, weighing them against the accumulated experience of your particular life. You did not choose to exist. You did not consent to be born. You did not sign any contract that stipulated the details of your existence, the family you were born into, the body you inhabit, the language you first learned to think in, the era in which you happened to arrive. All of it was simply given to you without asking. And one day, all of it will be taken back, also without asking. Between those two moments, the arrival you did not choose and the departure you cannot refuse, there is you. There is this consciousness, this stream of experience, this improbable arrangement of matter that has learned to say, I. Why? Not, why did evolution produce beings like you? We have plausible answers to that. Natural selection, cognitive development, the long unfurling of biological complexity. These are answers of a certain kind, and they are not wrong, but they do not answer the deeper question. Why is there this specific first person from the inside experience of being a particular someone in a particular here and now? Philosophers call this the hard problem of consciousness. It is the problem of explaining not just how brains process information, but why there is something it is like to be a brain that processes information, why the physical activity of neurons is accompanied by an inner life, why there is any experience at all. And this problem, on inspection, is a version of Leibniz's question turned inward. Why is there consciousness rather than no consciousness? Why is the universe not populated entirely by mindless matter, atoms bouncing around without any inner sense of what it is like to be an atom bouncing around? Why does the light come on inside some of these arrangements of matter, so that the universe includes not just objects but subjects, not just things but experiences? We do not know. Just as we do not know why there is a universe rather than no universe, we do not know why there is subjectivity rather than no subjectivity. And these two puzzles may be related in ways we have not yet understood. Perhaps consciousness is part of the answer to the question of existence. Perhaps a universe with no observers would not, in some sense, be a fully realized universe. Perhaps existence requires observation, or observation requires existence, or the two are aspects of a single deeper fact that we have not yet articulated. Or perhaps consciousness is just another brute fact, sitting alongside the brute fact of existence, both of them unexplained and both of them undeniable. Either way, you are here. You are asking. And the fact that you are asking is itself one of the strangest features of the reality we are trying to understand. The provisional nature of every answer. Notice something about the history we have traced. Every attempt to answer Leibniz's question has been, in some sense, provisional. The ancient myths offered stories that were later revised. The medieval theologians offered arguments that were later challenged. The Enlightenment philosophers offered analyses that were later complicated. The modern physicists offer models that are still being refined. At every stage, some thinker has stood up and said, "This is the answer. This is where the mystery bottoms out. This is the final unmoving point on which everything else rests." And at every stage, other thinkers have come along and shown that the proposed foundation is not as firm as it seemed. There is another level beneath it. There is another question to be asked. There is another way of looking at the puzzle that reveals its unresolved depths. Perhaps this pattern will continue indefinitely. Perhaps every future answer will also be provisional, awaiting the next revision, the next critique, the next reframing. Perhaps the question will always outrun our attempts to close it, or perhaps at some point we will reach a genuine terminus, an answer that does not admit of further questioning, either because it is complete or because we have become the kind of beings that no longer need to ask. We do not know which of these possibilities is more likely, but there is something worth noting in the pattern itself. The provisional nature of our answers is not a bug in the human project of understanding. It is a feature. It is what keeps the project alive. Every apparent conclusion opens onto new questions. Every apparent foundation reveals new depths. The mind that stops asking is a mind that has stopped growing, and the tradition that stops questioning is a tradition that has stopped being alive. The greatest thinkers in every era have understood this. They have offered their answers with confidence, because you cannot think seriously without confidence, but also with humility, knowing that their answers would be revised by those who came after them. Socrates said that he was wise only because he knew that he knew nothing. Newton said that he was like a boy playing on the seashore, while the great ocean of truth lay all undiscovered before him. Einstein, near the end of his life, said that the more he learned, the more he realized how much he did not know. These were not modest men in any ordinary sense. They knew their own abilities, but they also knew that the mystery they were trying to understand was larger than any mind that could try to understand it. And they were right. They were right about existence. They were right about consciousness. They were right about the fundamental structure of reality.